Welcome to the DIY Honda Garage channel. The DTC P0118 refers to an issue with the engine coolant temperature, ECT sensor 1 circuit, specifically indicating high voltage levels. This diagnostic trouble code is pertinent to various Honda models, including the 2008 to 2012 Honda Accord. The ECT sensor plays a crucial role in monitoring the temperature of the engine coolant, sending the data to the engine control module, ECM, for optimal performance, fuel economy, and good fuel, and emissions control. A faulty ECT sensor can lead to inaccurate data readings, which can affect engine timing, fuel mixture, and emissions controls. The ECT sensor is typically located near the thermostat housing, making it accessible for inspections and testing. Addressing this code promptly is vital to ensure the overall performance and longevity of the vehicle. The ECT Sensor 1 is designed to track the engine's coolant temperature, which is essential for maintaining efficient engine operation. It is positioned near the thermostat housing, a common area where coolant flow is regulated. This sensor continually provides temperature data to the ECM, influencing decisions regarding fuel injection, ignition timing, and emission control. If the ECT sensor reads a temperature of approximately -40 degrees Fahrenheit, -40 degrees Celsius, or registers a voltage of 4.92 volts or more, it sets off the DTC P0118. The consequence of a high voltage reading can lead to the engine running poorly, increased emissions, and major operational inefficiencies. Having accurate readings from the ECT sensor is essential to the vehicle's performance. Thus, any failure in this circuit necessitates immediate attention to prevent severe engine damage. Several factors can contribute to triggering the DTC P0118 error code. A faulty ECT sensor 1 often tops the list. If the sensor is malfunctioning, it cannot relay accurate temperature readings to the ECM. Another potential cause could involve wiring issues, such as damaged wires or short circuits that hinder the electrical flow. Poor connections or loose terminals at both the ECT Sensor 1 and the ECM PCM powertrain control module can also create intermittent failures impacting the sensor's functionality. Identifying and remedying these issues is crucial. Failing to do so could perpetuate the engine's inefficiency and emissions problems. Thus, thorough checks of the wiring and connections should be conducted to determine the root cause. When dealing with DTC P0118, various symptoms may surface, impacting the vehicle's operation. A primary symptom is poor engine performance. The engine may exhibit unusual behavior, such as rough idling, stalling, or lack of power due to incorrect fuel-air mixtures. Increased emissions can also occur as the ECM attempts to adjust to inaccurate temperature readings from the sensor. As a consequence of these issues, drivers may notice that the check engine light illuminates on the dashboard, signaling a problem that requires immediate investigation. Additionally, during winter months, vehicles may struggle to reach optimal operating temperature, affecting heater operation and overall comfort. Understanding these symptoms can help diagnose and rectify the issue efficiently. Initiate the troubleshooting process by turning the ignition switch to the on position, known as 2. Thereafter, access the Honda Diagnostics System, HDS, to review the data for the ECT Sensor 1. A critical part of this step is to ascertain whether the indicated temperature is approximately -40 degrees Fahrenheit, -40 degrees Celsius, or shows a voltage of 4.92 volts or greater. These parameters reflect an essential check of the sensor's functionality. If the values meet these conditions, it prompts the technician to proceed to the next troubleshooting step. Conversely, if the readings fall outside these thresholds, it suggests an intermittent failure within the sensor or circuit, leading to further inspection of connections and terminals. After confirming that the ECT sensor 1 readings indicate high voltage levels, the next step involves turning the ignition switch back to the lock position, also identified as 0. This ensures the electrical system is off, promoting safety before any further connections. Once the ignition is off, disconnect the ECT sensor 1 2P connector to isolate the sensor from the circuit. At this stage, it's imperative to prepare a jumper wire, which will be utilized in the following steps to effectively test the sensor circuit. This isolation is crucial to determine if the sensor itself is at fault, as it prevents any comments from surrounding circuitry from skewing the results of the tests that will follow. Now, connect the terminals number 1 and number 2 of the ECT sensor 1 2P connector using the jumper wire prepared earlier. This action forms a direct connection, bypassing the sensor itself to check if the circuit responds correctly. Turn the ignition switch back to the on position, 2, to re-engage the electrical system. Subsequently, revisit the HDS to monitor the ECT sensor 1 data again, checking whether the readings still remain around -40 degrees Fahrenheit or -40 Celsius, or indicate 4.92 volts or more is critical. If these parameters are verified as true, it implies that the wiring and connections are intact, leading you towards steps concerning further diagnostics or a suspected ECT sensor fault. Once the testing with the jumper wire has been completed, turn the ignition switch off to the lock position once again. This step allows for safe removal of the jumper wire from the ECT sensor 1-2P connector, ensuring no electrical hazards are present. It's essential to conduct this action delicately to maintain the integrity of the connectors and avoid any unintended shorts. Following the removal, turn the ignition switch back to on 2 to reapply power to the circuit. This process will lead to the next phase of testing, where additional measurements can be conducted that will help narrow down where the fault lies, depending on the voltage read at the subsequent step. In this step, a crucial part of the diagnosis involves measuring the voltage found between the terminal number 1 of the ECT sensor 1 2P connector and the vehicle body ground. This measurement is vital as it gauges the electrical supply to the sensor. Ideally, this reading should hover around 5 volts. If the voltage is confirmed to be within the expected range, this indicates the circuit is functioning properly, pointing towards a possible issue with the ECT sensor itself if earlier tests have confirmed circuit integrity. Conversely, if the voltage deviates significantly from 5 volts, this may indicate further issues in the wiring or connectors that need addressing. Correct interpretation of these voltage readings is vital to ensuring efficient resolution of DTC P0118. Upon completion of repairs and replacements as determined by the preceding troubleshooting steps, it is crucial to conduct a thorough test drive of the vehicle. This drive serves as a real-world check for the effectiveness of the repairs and helps confirm that the changes made have settled correctly within the system. During this test drive, monitor the vehicle's performance keenly, watching for any return of the DTC P0118 or any other related trouble codes. Importantly, check that the dashboard indicators, specifically the check engine light, do not illuminate during or after the drive. Successful verification ensures not just that the error code has been resolved, but also that the vehicle operates efficiently and reliably moving forward. To prevent future recurrence of DTC P0118, it's beneficial to incorporate regular maintenance checks focused on the ECT sensor and its associated wiring. Performing routine inspections of the sensor can help detect early signs of wear or failure before they escalate into significant problems. Additionally, it's advisable to conduct periodic examinations of wiring for potential damage, such as fraying or corrosion, that could disrupt proper functioning. Keeping all electrical connections clean and secure is equally critical. Dirt or moisture can create resistance and lead to faulty readings. Incorporating these preventive maintenance steps not only extends the lifespan of the sensor and its connections, but also contributes to the overall reliability and performance of the vehicle. In conclusion, the DTC P0118 signifies a high-voltage issue within the ECT sensor circuit, which is integral to optimal engine performance. Identifying the erroneous conditions and conducting a meticulous troubleshooting process can effectively resolve the issues at hand. Ensuring that the ECT sensor, wiring, and corresponding terminals are in good working order acts as a safeguard against running into similar problems in the future. Making it a routine to perform regular maintenance checks will enhance vehicle reliability. Ultimately, a structured approach to troubleshooting can lead to timely resolutions, ensuring not just the effective functioning of the vehicle, but also prolonging its lifespan and performance capabilities. Please like and subscribe to the channel. See you next time.